Hello friends, welcome to my YouTube channel. My name is Prathmesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
When interacting with a standard large language model, your conversation exists in a temporary, fragile bubble. Closing your browser tab shatters that accumulated context. This architectural reality is known as statelessness. By default, an LLM processes the exact text you provide in the current prompt, computes a response, and retains no memory of the interaction once the session ends. Without a backend database securely storing that conversational data, today, that entire infrastructure stack is generated through automated tooling. Engineering a permanent memory layer transforms the interaction from an isolated calculation into a continuous, personalized stream of data. The process begins with a single natural language instruction to an AI-integrated development environment. Add a database to remember preferences and past conversations. In a traditional workflow, satisfying that request involves significant developer friction. It requires selecting a cloud provider, establishing schema rules, authenticating user sessions, and writing the middleware to pass data between the front end and the new backend. The AI IDE intercepts the plain text request, generating the exact infrastructure on the right. It selects Firebase and Google Auth, dropping configuration modules into the project files. This sequence executes in seconds, replacing entire engineering sprints. The platform simultaneously writes the invisible binding layer. It creates the precise API calls needed to connect the user interface directly to this newly minted cloud database. Automation is streamlining the bridge between front-end interfaces and cloud backends, moving the developer's focus towards system architecture. Before writing a single line of database code, the automated system executed a critical prerequisite. It prioritized the application's first architectural decision: security. State requires identity. You cannot accurately save a user's preferences without a mathematical guarantee of exactly who that user is. To solve this, the AI built a Google Authentication layer. This forces a secure sign-in process, verifying the user via an existing credential standard. The authentication layer issues a unique cryptographic identifier to the specific session, acting as an authorization token. By utilizing isolated container architecture, the system guarantees user data cannot leak across sessions. User A physically cannot access user B's chat history. The AI builder recognized this exact security dependency autonomously, understanding that saving data into a shared cloud without strict identity verification renders the application useless. Without a secure authentication anchor, a personalized memory system is a critical security vulnerability rather than a feature. With identity verified, the automated builder implements Firebase as the dedicated state layer. Firebase is a NoSQL Cloud Database. It stores data as flexible, dictionary-like documents rather than rigid tables, making it the optimal choice for handling unstructured, highly unpredictable conversational inputs. When a user states their favorite movie, that data packet moves from the client through application logic into the state layer.
The database nests it into a JSON document under the user's identifier, and a confirmation signal instantly returns. This mechanical sequence is defined as the write-read loop, establishing the foundation for all real-time web applications. Because this specific NoSQL architecture operates with minimal latency overhead, these state updates occurred near instantaneously, keeping the conversation fluid. If this information were held in local, browser-based storage, clearing the cache would destroy it. By pushing it to a cloud architecture, the data achieves true persistence across multiple devices. Integrating this NoSQL Cloud layer is the precise engineering step that turns brief, ephemeral chat sessions into permanent, scalable user profiles. The data is secure in the cloud. The mechanical question becomes, how does the system physically apply these saved preferences when the user returns the following day? The millisecond a user reloads the application, the client triggers an invisible data fetch. The database authenticates and returns the user's document. Through context injection, these preferences are inserted atop the system prompt, hitting the LLM alongside the new message. The AI does not inherently remember anything. It is being fed a highly customized briefing document every single time it boots up. These system instructions form the critical invisible layer that governs the agent's tone, behavior, and personality, entirely based on the injected context. Long-term AI memory is ultimately an illusion. It is in effect engineered through highly efficient, automated pre-prompting architectures. We have examined the microarchitecture of a single user profile. We must now look at the macroarchitecture required for scale. Building a database for a personal virtual assistant is merely a proof of concept. It acts as the foundational building block for commercial software development. At scale, this infrastructure powers applications like automated Instagram direct messaging tools, SaaS platforms designed to handle thousands of concurrent interactions. This updated diagram shows the multi-tenant hierarchy. A single database now manages distinct logic rules for entirely different client accounts. An external trigger, like an Instagram API webhook, enters the system and hits a validation gate. The database verifies conditions before executing the payload. This represents the core engineering transition. We are no longer simply saving a user's movie preference. We are dynamically querying external states to trigger automated business logic. The foundational logic used for user persistence, binding data to a unique identifier, serves as the primary requirement for building high-volume automation tools. We have tracked the progression from a fragile, stateless chat window to a robust, multi-tenant webhook architecture. This evolution carries serious implications for modern developers and product managers regarding how software will be built moving forward. Complex backend infrastructure is now generated rapidly from high-level logical descriptions. Natural language coding environments abstract away the tedious, repetitive elements of backend engineering. Boilerplate code and manual server provisioning are handled by the system. The primary technical challenge is no longer writing character-accurate syntax. The challenge is architecting flawless, scalable system logic. Developers who master this natural language architecture will deploy full SaaS platforms in hours, bypassing months of traditional development time. In our next iteration, we will execute a complete teardown of that multi-tenant deployment.
We expect language models to remember us from one conversation to the next, but by design, their memory dissolves instantly. Every time you open a new chat window, the model starts completely blank. It possesses no historical context about who you are or what you discussed 5 minutes ago. In computer science, this constraint is called statelessness. A stateless system processes an input, generates an output, and immediately flushes its internal state back to zero. This rigid architecture prevents a standard model from acting as a continuous, reliable digital assistant. An assistant requires context to execute complex, multi-step tasks over time. Even with massive context windows, you are essentially working with short-term RAM. Once the window closes, the data is purged. There is no permanent hard drive attached to the model. Without a dedicated layer for persistent memory, a language model is simply a highly capable text calculator. To build a true autonomous agent, we have to engineer the memory infrastructure ourselves. A functional AI agent requires exactly two distinct capabilities: the authority to execute external actions and a persistent state of memory. The modern development stack allows us to bridge these two requirements, connecting an isolated text generator to external databases and APIs. We can now architect a fully stateful, personalized AI system without manually writing the backend syntax. Instead of writing hundreds of lines of boilerplate code, developers use AI-driven IDEs to generate complex infrastructure using plain English commands. The barrier to building software has shifted. Deploying a functional application relies entirely on your understanding of system architecture rather than your fluency in a specific coding language. We map this architecture with the foundational orchestration layer. This glowing hexagonal node is the core logic controller. Those text strings wrapping around it represent the system prompt, dictating rules, but offering zero long-term memory. To break the model out of its isolated environment, we introduce action hooks. These are predefined functions that give the model permission to interact with the real world. When a user inputs a natural language command, the logic controller identifies the specific intent. Once verified, it triggers the action hook. Watch as these geometric lines shoot out, routing the request to an external API. If a user asks to find a specific video, the controller fires an API request to a video platform servers, executing the search entirely in the background. Similarly, a command to play music triggers a precise query to a music streaming service, pulling up the requested track without the user ever opening the application. The external service then returns the results, the video links or the song data, feeding that raw information back into the logic controller.
The language model processes this raw data payload and translates it back into a natural conversational response for the user. Action hooks give the system the hands to manipulate the internet, but it still lacks a hippocampus. It executes tasks perfectly, but the moment the session ends, it forgets who it just executed them for. This architectural flaw becomes obvious the moment a user provides explicit personal preferences, like a favorite genre of music or a specific workflow setting. The model holds that data temporarily, but as this animation shows, when the context window refreshes, the container shatters. The preferences spill out and vanish. Fixing this requires connecting the logic controller to a permanent, continuous read and write NoSQL database. Historically, pairing a real-time database to a language model and managing specific user identities required months of full-stack engineering. This bottleneck priced solo developers and small teams out of building scalable software tools. By leveraging an AI-assisted IDE, we entirely bypass the manual database connection process. The workflow begins when the developer types a simple, clear directive. Add a database so the assistant remembers past conversations and user preferences. The IDE takes that natural language request and parses it into a complete structural blueprint for the backend. The AI autonomously generates the first critical backend file, handling the environmental configuration and security keys. It immediately generates the second file, establishing the exact routing protocols between the logic controller and the database server. Next, it produces the application logic, dictating exactly when the AI should save new information and when it should retrieve historical context. To ensure user data remains isolated, the system integrates secure user authentication, like a standard Google login. This guarantees the AI knows exactly whose memory it is accessing. Finally, the IDE generates the NoSQL schema, the specific organizational structure of the database itself. As this blueprint schematic unfurls, you can see how the schema maps a single, unique user ID directly to multiple distinct data nodes for preferences and chat history. This entire web of backend architecture, routing, and database logic was created without the developer typing a single line of traditional syntax. A backend setup that previously required months of manual development is now generated in the seconds it takes to process a prompt. Natural language has evolved into a direct compilation language for deploying entire backend infrastructures. Returning to our macro architecture, the massive storage cylinder drops in, connecting to the logic controller. The user authenticates, sending a secure token into the database. This retrieves their historical context, flowing data blocks into the central node before processing. The logic controller generates a highly personalized response and simultaneously writes any new facts back to the database. We have engineered a continuous, closed loop of memory, officially transforming a stateless model into a stateful, autonomous agent. This specific build is an AI assistant, but the underlying framework is universal. Look at how this completed architecture grid shrinks and duplicates across the digital landscape. This exact sequence, authentication, database retrieval, and logic controller processing, powers wildly different, highly profitable software-as-a-service applications. An automated social media tool, designed to detect specific comments and send targeted direct messages, runs on this precise loop. An enterprise e-commerce bot, handling thousands of real-time customer service tickets, utilizes the exact same structure. The specific personality, or the front-end function of the AI, is merely surface-level decoration. The true, highly scalable asset is the underlying stateful architecture we just generated. Building a scalable, full-stack MVP historically required a capital injection of roughly $300,000 to sustain a development team. Today, that capital requirement has shifted into the hands of anyone with a clear architectural prompt. The manual labor of writing code is being replaced by the strategic work of issuing natural language directives. This creates a new role for the modern developer: macro system orchestration. Instead of hunting for missing semicolons, developers focus entirely on mapping the logic flow and refining the user experience, leaving the code generation to the AI. When an AI handles the syntax, the only limit to what we can deploy is the clarity of our architectural vision. The builders of tomorrow will not be the ones who memorize the most code. They will be the ones who can architect the best